So, Jai Hind all. My name is Arun Kumar Maurya, Assistant Professor in the Department of Electrical and Electronics Engineering at AKGC Ghaziabad. In the continuation of my lecture series, the new subject is special electrical machines. So, in this subject, the very first topic is taken as stepper motor, and we will see the different types of special electrical machines: stepper motor, servo motor, SRM motor, and their various types of classifications. And we will see uh, as well as the most of the things which we see are in the surroundings, so we take it as a study purpose. So in this subject I will start from a very first lecture from the stepper motor. So if we see the content, so uh, first one is basic intro of stepper motor. uh, what is the definition, meaning, what is the type of stepper motor, we will see. Other point is that we will see the advantage and that is advantage of their stepper motor. And after that we will look into their applications of stepper motor and their classifications of stepper motor, and introduction of variable reluctance type stepper motor. Basically, variable reluctance is reluctance type stepper motor is the classification of uh, the broad way of stepper motor. So first we will see the what is stepper motor and what is the working principle, main objective and thing about the stepper motor. So basically a stepper motor is a special electrical machine which rotates in a discrete angular steps in response to a programmed sequence of input electrical pulses. In the other meanings, stepper motor works on the principle of an uh, basically a stepper motor works on the principle of rotary rotary involvement of a rotor with excitation uh, of a pulses given to the motor. Basically, it's uh, rotates in the form of input pulses. So when we will see, I would wish to rotate the rotor at a angle of 15 degree. So the suitable motor is taken to be considered as stepper motor. The stepper motor works on the principle of doing rotation in the form of rotary motion as a excitation of triggering or a pulses. Pulses are, these are the electrical pulses. So if we see the principle, a magnetic interaction takes place between the rotor and the stator, which make responsibility of moving the rotor of a stepper motor. If we see the construction, so these are the stator and the rotors. The stator has the windings, and the rotor is of salient pole structures without any windings, and it may or may not have permanent magnets. It's a main thing. The rotor is of salient structure without any windings. The stator has the windings, but in case of a rotor, the rotor has no windings in their structure, and it may or may not have permanent magnets. Okay. So if we see the advantage of a stepper motor, so we will see the one by one and their utilization and the advantage of stepper motor. Basically, a stepper motor is widely used for our electrical, electronics, industrial, commercial, and the domestic purpose as well. And here, here happily to see the response of a stepper motor in surroundings as well. So one by one we will see. Stepper motor are used in the automated production equipments and automotive gauges in industrial machines like packaging, labeling, filling, cutting tools, etc. It is widely used in security devices such as security and surveillance cameras. It is used in a drone and the surveillance purpose also, and it is widely used to capture the data while the rotation of an angle such like that 15 7.5 3.75 and the very minute angle we may obtain by this motor. In the biomedical industries, stepper motor are widely used in samples, digital dental photography, respirators, fluid pumps, and the blood analysis of machinery and the medical scanners. So, in the biomedical field, it is widely used. They are used in the consumer electronics, in the image sensors, photocopy machine, and the printing machine as well. In the digital cameras, automatic zoom and the focusing, functioning, and the positioning purpose, this stepper motor is used. Stepper motor also used in elevators, conveyor belts, and the lane diversity also. At standstill position, the motor has full torque, no matter if there is no movement or changing the position during the operation. This is the feature of an feature of a stepper motor, and it has a good response to starting, stopping, and the reversing position, because the response is high and there is no much uh, requirement of high starting and the high starting torque, uh, and the current as well, and the connection of removing the directions and and to the change it. So these other requirements are very less, and you can say that there is no requirement for sudden change to connect or remove for a stepper motor, because it has a very good response as starting, stopping, or the reverse during the operation. So this is a flexibility by using this stepper motor. Other side we will see, as there is no contact brushes in the stepper motor, so the reliability is high and the life expectancy depends on the bearings of the motor. The motor rotor angle is directly proportional to the input signal that carries the input electrical pulses as a triggering. Okay, it is simple and less costly to control as motor provides open loop control when responding to the digital input signals. This is the main thing, open loop control system. Other point is the motor speed is directly proportional to the input pulses frequencies, and this may a wide range of rotational speed can be achieved at a particular angle. And when the load is coupled to the shaft, it is still possible to realize the synchronous rotation with a low speed. And this is a very important point. The exact positioning and repeatability of movement is good, as it has 3 to 5% of accuracy of a step. Step is nothing like that. Step is a discrete movement with excitation of input pulse. So where the error is non-cumulative from one step to another. So if we see the accuracy point of view, it is good. Stepper motors are safer and low cost as compared to the other conventional motors, and uh, one motor, that is servo motors as well, which having high torque at low speed and high reliability with simple construction which operates in any environment. Okay. Other point is disadvantage of stepper motor. Stepper motors having low efficiency. It has low accuracy in some of the applications when we required a large response of a different connected loads, so it has low accuracy. The torque declines very quickly with speed. This is the major disadvantage while we see the stepper motor. As stepper motor operates in a open control loop system, so there is no requirement of feedback because feedback is only used when the closed loop control system is required. In the previous slide, I have discussed as the stepper motor is a open loop control system motor, so there is no requirement of feedback, and which is not using so much of feedback and the other mechanism as compared to the other motors. Okay, it has low torque to inertia ratio means which it cannot accelerate with a load very quickly. They are noisy in nature. Okay, so these are the some major disadvantages of stepper motor, while we will see the response taken from the multiple load connected to the system, because the stepper motor is used for a small scale applications to start and initiate the low responsive of machines. If we see the applications of stepper motor as discussed earlier in the introductory session, this motor is widely used for electrical, electronics, defense, security, surveillance, pumps, conveyor belts, and other systems as well. And we will see the application of stepper motor in so many diverse areas from one point to the major point. This is ranges to be seen as a small wrist watch to the artificial satellites. So this motor is widely used for their different purposes. The generally the power range is 1 watt to 2.5 kilowatt. That is 2.5 kilowatt. And the torque range is 1 micron to 40. Okay. Other point is that the broad classification and the types of stepper motor. So we will see the types of stepper motor. So the first type is variable reluctance type stepper motor. This is the very first type or classification of stepper motor, variable reluctance type stepper motor, which is further classified into the two categories. First one is single stack variable reluctance type stepper motor, and the other side multiple stack variable reluctance stepper motor. In the single stack variable reluctance type stepper motor requires only one stack. Okay, and as large as we see the response of an electrical machine, we will see the multiple stacks ranging from 1 to the number of n's. So 1 stack, 2 stack, 3 stack, 4 stack, up to the n stack. So this classification is divided into the two parts. First one is single stack variable reluctance type stepper motor, and other one is multiple stack variable reluctance type stepper motor. And we will see the broadly classification of stepper motor. The second category is permanent magnet stepper motor, and the other one is hybrid stepper motor. These all types of stepper motors would discuss in a detail in the upcoming lecture series. Okay, if we see the variable reluctance type stepper motor, so this type of motor works on the principle that a magnetic material placed in a magnetic field experience a force to align the minimum reluctance path. So it has two types: single stack, and this is multi stack variable reluctance type stepper motor. We will easily see the basic structure of stepper motor, that is 4-phase 8-pole single stack variable reluctance type stepper motor. So if we see the single stack variable reluctance type stepper motor, so if we see the construction, this has two parts. First one is stator and second one is rotor. If we see the stator part, the stator made up of silicon steel in steppings, and it has projecting poles, usually a even number of poles in its construction. The poles carry concentrating windings on its structure. If we see the rotor part, it also usually made up of silicon steel stampings, and solid silicon steel also used for to core of the rotor of its single stack variable reluctance type stepper motor. The rotor has projecting teeth on its outer periphery. Teeth are nothing like that, these are the poles. So the last point is very important, and which is useful for to remember. It may be asked in a university or a conventional or your interview questions as well. So the point is the number of rotor teeth and stator poles should not be equal. This make motor self starting. It's a very important point. Okay, when we will see the switching sequence of single stack variable reluctance type stepper motor, so these are the switching network or switching sequence. So we see these are the windings A and A dash, B dash, C dash, and D dash, which carries a corresponding switches, that S1, S2, S3, and S4. So we will see the pattern of the rotation of a rotor when we will see the operating principle and the working structure of single stack variable reluctance type stepper motor. So in this case, when the phase A is energized, so A and A dash is in a excitation condition, and switch 1 is closed. So other switches are open, so this value to be taken as 0. So the rotor is at a 0-degree condition. Okay, when the phase B is energized, so B and B dash windings are excited and the switch 2 is closed. So S1, S3, and S4 are kept to be open. So this is 0, this is 0, this is 0, and corresponding switch 2, and that corresponding the windings V phase windings, that is B, is to be closed, that is 1. So the angle is 15 degree. So the rotor moves with a displacement of 15 degree. Okay, when the phase C is energized, so the C and C dash windings are excited with corresponding S3 is closed with respect to switch 1, switch 2, and switch 4 are closed. So the rotation angle is 15 degree increase from the previous one and 30 degree from the initial state condition. Okay, when the phase D is energized, excited, so D and D dash is also excited. So we will see the switch 1 0, switch 2 0, switch 3 0 with corresponding to the phase D, and in S4 it is closed. So the angle 15 degrees more increase with corresponding to the previous one. So this is total 45 degree from the initial state. So uh, we will see the we will in we will move to the increasing manner at a particular duration of an angle that is 15 degree. So this is the switching pattern of single step variable rectangle stepper motor. This is the truth table or a switching sequence for variable rectangle stepper motor. So if we see the modes of excitation, and there are the different three types of mode on which the variable reluctance stepper motor is working. So first one is single phase or full step on mode, and other one is two phase on mode, and last one is half step mode on which the variable reluctance stepper motor works. So these are the excitations we will look after in the upcoming lecture series. So I think this is clear, and if some doubt, we will see in a regular classrooms.